Okay then, let's say here I am. Hi, I'm back. This is a can right here. I had a really rough start on the last video, and I'm starting over again. So, uh, you're a collector of gases. I know maybe you've accused other people of being the same, or maybe the people you know disperse gases, but that's disgusting. We're not going to talk about it right now. We're going to talk about neon. 350 grams of neon in a 15-liter container. Let's ask a funny question. If the pressure inside this container of 350 grams of neon is, let's just say, I don't know, pressure is equal to 21. Is that even possible? Yes, it is. Okay. I was just getting all the pieces together in my head. That shouldn't really be capitalized, but, well, yeah, sure, we'll be the chemistry grammar Nazis. ATM. There we go. Okay, so the pressure in this container is 21 atmospheres. It's 350 grams of it, and there's 15 liters. And I want to know, how hot is it in there? Or not. Okay, so let's just take a look. We can use the ideal gas law to figure this out, right? The ideal gas law says, what does it say? It says hi. Okay, how's your mom? It says PV equals NRT. Got it? Okay, good. Let's go with that. So all I need to do now is just plug things in. I know that 21 atmospheres times, it occurs to me that since I'm solving for temperature, maybe before I do all this, let's rearrange things a little bit, okay? If I divide this whole thing by NR, then I'll have T alone and I won't have to do any yucky manipulation and potentially mistakes in the future. So let's do that. Let's say T is equal to, do you see what I'm doing there? I'm just saying let's multiply all this by 1 over NR. The whole equation, both sides, right? That's just algebra, okay? And that gives me T equals PV over NR. Okay. Now, I don't mean to create the impression that this is going to be totally easy, because we know a few things just by looking at this. We know, first of all, well, these should be pretty easy, right? Pressure and volume, because I've given them to you. The N, that's a little bit tricky. You can get messed up there. The R is given to us as well. So really what I need to do is say 350 grams. How many moles of neon is that anyway? So let's do that first, okay? I've got 350 grams of neon. Okay, and I take that 350 grams, and I want to know how many moles it is, because I'm dealing with moles, not mass here, okay? Number, that's what the N is for. So I come over here, and I say, well, 1 mole of this stuff is going to be equal to, and I look at my trusty periodic table. It says it's equal to 20 point, I printed that too small, 20.180. I got to buy a poster. 20.180. Okay, so 1 mole of neon has 20.818 grams. Okay, so that conversion, let's do the math. Calculator, where are you? Ah, yes, here it is. Okay, it's a boy. I won't tell you how I know. Okay, so this is it. 350. Yes, okay, 350 grams divided by 20 grams that there are in a mole, 0.180, and I hit enter, and I divide it, because this is my HP, and that comes out to, wow, that's a lot of, well, I guess it's a lot. I don't really have anything to compare it to, but that's 17 point, let's see, got 2 significant digits here, that looks like. But actually, I'm not going to worry about that right now, because I'm not done calculating. So 3439 moles. Okay, so now the rest of it should be pretty easy. Let's zoom out just a little bit. I say out. See, the calculator does what I tell it to. Photoshop, well, actually, Photoshop's fine. Okay. A little further, a little further. I need more RAM. Okay, here we go. So, new color. Yeah, this, you like, uh-oh, this is not good. Okay. So now that I have this number here, I can start filling things in. I'm going to say the temperature is equal to, we said pressure, which is 21 atm, pressure, times the volume. And I said that was 15 liters. It's a pretty big container, right? And let's see, I'm going to divide that by N. The N is this number, so that's 17.34 moles of neon, right? And then the last thing I'm going to do is multiply that by the universal gas constant, which is, in the units we're looking for, going to be 0.08206. What? Well, that's the tricky part, right? It's liter ATMs per kmol. Got it? Good. Okay. Now, let's look at units. If we're going to be thorough about this and make sure it all cancels out. Okay, this would flip and end up canceling with that, right? This is the temperature right here. The liters will cancel out also. Like they're the moles. This cancels with this one. And that leaves me with a K. That's exactly what I wanted to see happen. So let me come over here. Okay. And where did I get that 17 from? Oh yeah, that's my mole number. Let's go ahead and use that. Okay, so let's make it confusing, shall we? 17.34 times 0.0826. And I'm going to multiply that. Okay, that's my denominator. Now I'm going to say 21. Oops. Try that. 21 times 15. Okay, that's my numerator. So I better flip them before I do the division. And I divide that, and I get 219. Oops, not that. So the final temperature of my container, to get all my neon to fit in there, that pressure is going to be equal to 219. Well, actually, let's go sig figs. That's going to be 220 Kelvin. Okay, and that's it. Now you know what the temperature is inside. I guess we could, look at that maybe in terms that's a little bit more familiar. They're a little bit more familiar. So let's say 273.15 and subtract that. So that's going to be, wow, that's going to be pretty cold, right? 53 below Celsius is what it's going to take to fit a mere 350 grams of neon into a space that's only 15 liters. So, you could lift it easily, but your hands would get hurt because they'd be freezing. There's my, look, that's running away from me again. All right, well, anyway, I hope that helped, and good luck on your tests and learning. Learning mostly, though. Bye.